Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.87. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is always equal to the product of current through that resistance and the value of resistance. Parallel equivalent resistance calculation formula will also be utilized while solving this problem. R equivalent of two parallel connected resistances is calculated by taking the product of both resistances dividing by their sum. Now move towards the problem. Exercise problem number 2.87. Find the value of current Is in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find the value of total supplied current labeled as Is. So without wasting time, let's proceed towards the solution. First of all, we will try to simplify this network. These two resistances are connected in parallel connection. We will find their equivalent resistance and replace that equivalent resistance with these two resistances. We will use this equation to calculate their equivalent resistance. In this case, R1 will be 6 kilo ohm and R2 will be 3 kilo ohm. Place values inside this equation. Product of 6 kilo ohm and 3 kilo ohm divided by the sum of 6 kilo ohm and 3 kilo ohm. Product of 6k and 3k will become 18k square and sum of 6k and 3k will become 9k. 18k square divided by 9k will result 2 kilo ohm. So we can replace these two resistances with a single resistance having the value of 2 kilo ohm. Modify the network. Now we will label these two branch currents in order to calculate total supplied current. This branch current will be labeled as I1 and this branch current will be labeled as I2. And we are labeling these two branch currents because later on we will apply Kirchoff's current law on this node. Voltage across this 10 kilo ohm resistance is given in this scenario, so we can calculate current through this 10 kilo ohm resistance using Ohm's law. Current I through this resistance will be equal to 5 volt divided by the value of resistance 10 kilo ohm. It will become 0.5 milliampere. 0.5 milliampere current will be flowing through this 10 kilo ohm resistance. Direction of current will be clockwise direction because this terminal is positive, and in order to make this terminal positive, the current should enter from this point and leave from this point. That's why the direction of current inside this 10 kilo ohm resistance will be clockwise direction. Now because of the series connection, this same current will also flow from 2 kilo ohm resistance with same direction and same magnitude. So we can say that the value of current I1 through this branch will be 0.5 milliampere. We have calculated the value of current I1. Now we can calculate voltage across this 2 kilo ohm resistance as well, because current through it is calculated in previous step and the value of resistance is already given. So using Ohm's law, we will calculate voltage across this 2 kilo ohm resistance. That will be the product of I1 and the value of resistance. Voltage across 2 kilo ohm resistance will be the product of 0.5 milliampere and 2 kilo ohm. It will become 1 volt only. So 1 volt will be appearing across this 2 kilo ohm resistance. Voltage polarity across this 2 kilo ohm resistance will be positive terminal here and negative terminal here because current entering terminal is taken with positive sign. Now we know the value of individual voltage across these two resistances, so their sum will be equal to voltage across this constant current source, and same voltage will be appearing across 4 kilo ohm resistance as well because of parallel connection. We are assuming voltage V is between these 2 points, and these voltage V will be equal to the sum of 5 volt and 1 volt. Voltage V will be equal to 6 volt. Now 6 volt will be appearing across this constant current source as well as 4 kilo ohm resistance because of parallel connection. From this point, we can calculate the value of current through this 4 kilo ohm resistance because voltage across it is calculated, that is 6 volt. So using Ohm's law, we will calculate current through this 4 kilo ohm resistance, that will be equal to I2. I2 is equal to 6 volt divided by the value of resistance 4 kilo ohm. So the value of current I2 will be 1.5 milliampere. And the direction of current through this branch will be counterclockwise, leaving from this node. Now we can apply Kirchoff's current law on this node to calculate the value of current Is. Current Is will be equal to the sum of both leaving currents because only one current is entering and two currents are leaving. So the value of Is is equal to I1 plus I2. Place values of I1 and I2. Value of I1 is 0.5 milliampere and value of I2 is 1.5 milliampere. So the value of Is will be 2 milliampere. This was exercise problem number 2.87. Thank you. See you again in next video.